Let's understand the build process and we can later try this practically. Let's say you have main.c. When you first invoke the compiler to compile your source file, first stage is pre-processing stage. In this stage, all pre-processing directives of the source file will be resolved and the output file main.i is created. For main.c, main.i is created. This is not compilation, remember that. This is a pre-processing stage of the compilation, which is usually done by the compiler itself. The pre-processing directives such as all hash includes, the C macros, or the conditional compilation macros of the source file will be resolved and a pre-processed file is created that has the extension of .i. After that, what comes is the code generation stage, that is translating a source file into assembly language. That is, if the input is main.i, then output will be main.s. Here what happens is higher level language code statements will be converted into processor architecture level mnemonics. Higher level language in this case is C, isn't it? C statements will be converted into the assembly level language. That's what we call as mnemonics. After that comes the assembler stage. All these things will be done by the compiler itself. You need not to invoke any other command. Everything will be done by the compiler. In our case, the compiler is ARM none EABI GCC because we are doing the cross compilation. In the assembler stage, the assembly level mnemonics are converted into opcodes. Opcodes are nothing but machine codes for various instructions, because at the end of the day, the target or the processor understands numbers or machine codes. That's why the assembler does this job of converting the assembly level mnemonics into the machine codes, and it creates the output file called a relocatable object file. If the input is main.s, then output will be main.o. That's what we call as relocatable object file. I'll explain you what exactly I mean by relocatable. So I will explain that later. This is a whole process. In our case, we have got two source files, isn't it? Main.c and led.c, which will undergo pre-processing and after that parsing, where some checks will be carried out for the C syntax. After that, it goes into code generation unit of the compiler. The output will be .s file, and in the assembler stage, assembler converts the .s file, that is assembly level mnemonics, into machine code. It generates the output file .o. .o contains processor architecture specific machine codes with no absolute addresses. That's the reason why it is called as relocatable. The machine codes which are stored in .o file, they don't carry absolute addresses of the program memory. They carry an address which can be relocatable. We'll explore that later when we do this compilation practically. This is a process of converting high-level C code to machine codes. Remember that, so you can't see all these .i and .s files unless you instruct the compiler to save those files. We can do that. But by default, compiler doesn't save .i and .s files which are created in between the process. After that comes the linking stage. All the relocatable object files will be taken up by the linker. It will resolve all the symbols and other information, and it will merge the different sections of the .o files to create one executable, that is the final executable, and the format of that executable will be .elf. .elf stands for executable and linkable format. All relocatable object files are merged together to create one executable. After that, you can take that executable which is in ELF format to create some other formats such as binary format, which has the extension of .bin, or you can convert that ELF file into Intel hex format using the tool object copy. This is a complete build process. In summary, the first comes the pre-processing, followed by compilation, followed by linking. And all these steps will be carried out by using only one binary, that is ARM none EABI GCC. Only one command you have to run, which does all these steps. You need not to explicitly invoke assembler or linker like that. So you need not to do that. You can just use one command. In the next lecture, let's run this command to cross-compile our .c files. I'll see you in the next lecture.